The aim of our project is to design a drone delivery container that can deliver medical supplies to remote and inaccessible areas. The device needs to be lightweight, easily openable, condition resistant, and low cost. The average EMS response time in rural areas is around 14 minutes, and some areas are difficult to navigate through. So our drone delivery container would allow the faster delivery of Narcan, insulin, and AED to patients.
Our final design consists of a nylon outer casing lined with Insulbrite, which is an insulating fabric. It also includes a polycarbonate lid that has lips that wrap around the top edges of the foam enclosure. There is a nylon handle to allow the user to easily pull out the lid in order to gain access to contents of the box. As such, the nylon outer casing is sewn together utilizing the agreed upon dimensions of the container, and the Insulbrite is sewn to the inside of the nylon casing.
I first wanted to address the actual shape of our design solution and our box. So we decided to use a rectangle because we felt it was more intuitive for the big age gap that we have to address, which is 15 years old to 95 years old. So within our box, we actually have a foam insert that we decided to create. So this foam insert provides two things: thermal control, where it prevents heat from escaping or heat entering the actual enclosure itself rather effectively. And another thing that it addresses is actually payload protection. Main feature of actual foam insert itself is how it has three different individual inserts in it, where the smaller inserts hold the AED, the Narcan, and the bigger insert actually holds the AED, and the smaller inserts hold the Narcan and the insulin. So the AED is 9 inches by 7 inches by 2 inches, while the insulin and Narcan are substantially smaller within the actual insert itself. Regarding the dimensions of the box, we decided on making the height 5 inches, while the base is 8.25 inches by 11.25 inches. So another key feature that we decided to address was how we have a 2-flap system, as you can see here. So the upper flap point has an arrow that we sewed on and painted red, which allows the user to see it, whether it's light or dark out. So again, you can open this 2-flap system, which actually utilizes Velcro, which again addresses a design block regarding ease of use, which is a main design criteria as specified by our client. And the second flap, which has another arrow, also utilizes these sort of gripper pull tabs, which are on either side. Where, let me demonstrate. If you can hold this side of the pull tab and then hold this side, you can open it rather easily.
After calling EMS, a drone will deliver our box. When the box falls from the sky, you will immediately see the red arrow pointing to the first handle. We have 2 grip tabs to counteract the force of opening it. Once that's open, you'll see this second red arrow, which will prompt you to do the same thing as you did for the first opening. Then you'll see inside there's a lid to protect the contents. So you'll pull out the lid, and then you'll find your AED, Narcan, or insulin in one of these containers.
Next, we will discuss the success of our prototype in meeting the design criteria. The prototype was to weigh no more than 5 pounds, and this version of the prototype weighs 1.2 pounds. The container was to hold up to 400 cubic inches, and the styrofoam insert within the container holds approximately 250 cubic inches. We tested water resistance by holding the box under a water shower for 10 minutes. The water ran off the outside of the box, and we found no water accumulation in the interior of the box. To test the container's durability, it was released from a height of 2 feet 50 times. No internal or structural damage resulted.
The container must stay at an internal temperature of 0 to 120 degrees Fahrenheit. Using a thermometer, the initial temperature of the box was 74 degrees Fahrenheit, and when placed in a freezer of 30 degrees Fahrenheit for 10 minutes, the internal temperature of the container drops to 55 degrees Fahrenheit. Our next design criteria is the protection of contents. When the container is dropped, we need to make sure the contents are not damaged. We placed a hard-boiled egg in the foam insert and dropped the container 20 times. The hard-boiled egg did not crack.
Our future plans include replacing the current acrylic lid with a lid made of polycarbonate material to increase the strength and reduce the weight of the box. We want to do actual testing with a drone to see how well the device performs in the field. And we want to continue to get feedback from our client and make adjustments to the box as necessary.